So, after the locolith, one of the major form of igneous rocks is batholith. Okay, and batholith again are the largest kind of intrusive bodies, irregular in shape and occupies very large area as compared to dikes and all that we were talking about, that they were vary from 10 to 100 meters and all that, but this will occupy very large. So, like other igneous forms or the structures, batholith is another structure which is one of the largest kind of intrusive body, which is irregular in shape and occupies very large area as compared to the other forms which we have discussed, like dikes, sills and all that. Okay. Now, if you look at the batholith, it will have like almost like tens of kilometers it will cover at the basal part, and on the top area the which is going towards the surface is termed as stock. Okay, and that will be having again it covers an area of about few kilometers. Okay, but batholiths are mostly the areas which are which covers larger region. Okay, in terms of if you take the compare with other igneous structures or the other igneous intrusive bodies. So, these are having the slopes, if you take it is dipping away from one another. Okay. Hence, we see at the greater depth you will find that they are covering very large areas. Okay. So, their occurrence is commonly associated with mountain building activity. So, where we are having subduction zones and all that, we will find this type of intrusive bodies. Okay. And the batholiths are either comprised of granite or granodiorite in composition, and the another associated intrusive body is the stock. Okay. So, stock as we were talking about, that it will be of few kilometers. Okay, and it may be around 10 kilometers in maximum dimension, and they are always associated with the batholith. So, batholith will cover larger area at the bottom, and then on the upper part we will see the stocks. Okay, and this is one of the best example of stock or the batholith in US, California. Now, there is another one which is termed as bismullith. It is a cylindrical shaped body again. Okay, and what we see is that that this is very much similar to the locolith, but we find this as an intrusive body within dike at the in the at the depth, and the top we have some intrusion like what has been shown in the figure. Okay. So, mostly it is developed when highly viscous magma, which is acidic in nature, is injected below because of the lateral spreading along the bedding. Okay, and it requires to move upward and form a cylindrical shape. Okay. So, this is the body which is termed as bismullith. Okay. So, we move further and look at the variety of igneous rocks. So, formation of igneous rocks and identification criteria will see how we can differentiate one rock from another, and how we can differentiate whether it is an intrusive rock or it is an extrusive rocks. Okay. So, as we discussed in the lecture of mineral different type of minerals, we looked at the continuous and discontinuous series, and we discussed about that how the minerals are formed at different stages, and as we have discussed in the beginning, that cooling of magma will affect the formation of different crystals and formation of different minerals. Okay. So, please recall this two series, that is discontinuous ferromagnesium series and the continuous non-ferromagnesium mineral series. Okay. And so, the combination of these minerals will usually will be able to see that the different type of rocks in different type of rocks, okay, of igneous rocks mainly. So, as for example, if you take granite. Okay. So, granite is comprised of orthoclase feldspar, then you are having quartz, then you are having biotite and plagioclase feldspar. Okay. And so it is mostly the aggregate of different minerals, okay. And that is what we were talking about, that what is rock. If you take rock is an aggregate of different minerals. So here we are having number of minerals: pyroclastic, orthoclase, biotite and quartz, okay. So we have that is the composition of the. So different rocks will have different composition, and we will learn as we move ahead in this course, while talking about different type of rocks, that this minerals will also provide strength to different rocks, okay. So hardness of the rocks, the durability of rocks in terms of the weathering will depend on the constitution or the composition of different minerals, okay. And you have to remember the hardness, Mohs hardness scale, which will also help you in understanding that which mineral is harder and which mineral is softer, okay. So harder and softer will also will have the effect of weathering, okay. So the harder minerals, like for example, you are having quartz is 7 hardness, is much comparatively harder, and most of the rocks will have this one, okay. The rest of the minerals will get eroded or withered, but this will be will remain in the deposits, okay, or the rocks. So let us move ahead and see. So this is again comparison of the Bowen reaction series, different type of minerals which have been formed with the continuous series and the discontinuous series here, and with the different composition, different rocks are been named here. So we will talk in detail about what is basalt, what is gabbro, andesite and diorite, rhyolite and granite, okay. Now these are the different rocks which we will see that how they are classified as an extrusive rock or intrusive rocks, okay. So as the temperature decreases and the increase in silicon percentage, okay, in the liquids, different type of rocks are formed, and different rocks are comprised of, or they comprise different minerals here, okay. So the another most important other than the composition is, this is the criteria which we will follow to identify the rocks, is the texture, okay. And we have different type of texture, and textures are again which are been classified based on the grain size mainly. So we have the textures which are associated with the intrusive origin, and the textures which are associated with the extrusive origin, okay. So as we have discussed in the previous lectures, that fast cooling, okay, will result into the fine grain crystals or the fine crystals formation, or and the slow cooling will result into the coarser crystals, okay. So based on the size of the crystals, they have termed as the crystals having the size greater than 1 centimeter, very slow cooling. Hence we talked about they are not coming right up to the surface, so they are intrusive in nature, okay. So they remain below surface, and cooling is very slow, okay. So they are termed as pegmatites, and then crystals which are having the size around 1 to 10 mm are termed as Porphyritic texture. And then we are having larger and smaller crystal, that is a mixture of larger crystals larger than 10 mm or larger than 1 centimeter. So, and then we are having a ground mass, what we say, this is the ground mass here, and then we are having the larger crystals here which are surrounded by the ground mass. So this type of texture is termed as Porphyritic texture. And then we are having if you move into the extrusive rocks further down, and then we are having finer ones, that is aphanetic texture, glassy texture, vesicular and all that, okay. So aphanetic is having like less than 1 mm, rapid cooling of magma, whereas here if you look at what we see in porphyritic, let us just slow, and then so initially there will be in slow cooling which will result into the formation of larger crystals, then there is a rapid cooling which is probably because of the change in the magma viscosity or the composition, okay. So they will have different composition here, and that is why it results into the formation of larger and smaller crystals. Whereas if you look at the aphanetic texture, which is having the crystal size less than 1 mm, will be rapid cooling or very fast cooling will be seen in terms of the glassy nature of the rocks. Okay. Then we are having vesicular, and then we are having pyroclastic and all that. This will talk as we move further while talking about the eruption of magmas and all that. Okay. So mineral composition is again an important criteria, as we have been discussing right from the beginning when we were talking about the mineral formation and all that. So mineral composition is one of the major criteria to identify the rocks. Okay. So we are having feldspar and silica rich rocks, and we are having mafic, magnesium and iron rich rocks. We are having mafic rocks. Now mafic rocks are basically mostly darker in colors. Okay. And the felsic rocks are mostly or the felsic minerals are lighter in color. Okay. So the rocks which are comprised or are having the composition more of mafic minerals, okay, will give you the darker colors. Okay. Whereas the rocks which are comprised of felsic minerals will give you the lighter color. So looking to the rocks in directly, one can identify and one can say that, okay, fine, this is felsic rich rock and this is mafic rich rock. Okay. So felsic, mostly what we see is quartz. Then we are having plagioclase, plagioclase or potash plagioclase, muscovite, mica and all that. Whereas if you move another variety of mica is biotite, which is a mafic rich, and then we are having amphibole, pyroxene and olivine. So these are very important color index which you can use to identify the rocks along with the texture part. Okay. So texture is a crystal size, and then how the appearance we see of the rock surface, and then the mineral composition. So based on the color index, you can identify the felsic and mafic one. Okay. Then coming to the other part, which again is the type of magmas. If you look at, okay, so if you look at the type of magma, we are having felsic, which is light, okay, and then we are having intermediate mafic, which are darker, and ultramafic. Okay. So it shows that the felsic are normally lighter colored minerals, and mafic, ferromagnesium, normally darker colored minerals we are having. So these are been grouped in the darker colored minerals: olivine, pyroxene, amphibole and biotite, whereas lighters are potash, feldspar, plagioclase, quartz and muscovite. Okay. So this is based on the color index. So if you move towards the side and you are having more of the mafic minerals, then you will see the darker colors, whereas you are having lesser mafic minerals, you will have lighter colors having felsic minerals. Okay. So this also indicates that if you move from the lighter minerals to the darker one, you will have decrease in silica percentage, whereas if you move towards the other side, you will have increase in silica percentage. So this is one thing. And different type of rock, as I was talking about, then we can have the lighter ones. We are having rhyolite granite, we are having andesite diorite, we are having basalt gabbro, and then we are having basalt and dunite or peridotite. Okay. So these are the rocks like dunite and peridotite, which will comprise almost 90% of olivine. Okay. So ferromagnesium mineral we are having. So let us see one by one how this different type of rocks looks like in nature. Okay. So we are having ephenetic rocks, which are fine grained. Those are the rhyolite, andesite, basalt, and then basalt, orvin rich basalt and all that. And then we are having pheneritic, coarse grain, okay, which are granite, diorite, gabbro. So now if we just recall and compare this with the cooling process, okay, then we can also justify that which one is the intrusive and which one is the extrusive. Okay. So intrusive are the coarse grain, because the cooling of magma is slow here, where the cooling of magma is faster here. So we are having ephenetic. So this all rocks which have been listed here are the extrusive rocks, whereas the granite, diorite and gabbros and etc. are the pheneritic coarse grain, are the intrusive rocks we are having. Okay. So this is the table which talks about, one is the origin, whether it is an intrusive or extrusive rock, the intrusive or extrusive rock. Then we are having texture, where we classify based on the crystal size or the grain size we are having. So, we say pegmatite, pheneritic, porphyritic, etc. Okay, and then we are having rock names. Okay, and that is based on the chemical composition. So, this all combinations if you take, you can easily identify the rock, and you can say whether it is an extrusive rock and intrusive rock. Okay. So, texture of igneous rocks, if you look at based on the granularity of the grain or the grain size we are looking at. Okay. So, grain size depends again on the physical conditions that prevail during the time of crystallization of magma. Okay. So, slow cooling will give rise to larger mineral grains, and fast cooling will result into the smaller mineral grains. Okay. So, hence we see that these are finer grains and these are coarser grains. Okay, and these are related to the extrusion, and this is intrusive rocks. Okay. So, pheneritic texture if you look at, so what we see is the coarser minerals. Okay, or the crystals. Okay. So, it is characterized by larger size minerals which can be easily seen by naked eyes. Okay. Size is at least 2 mm or greater, and commonly associated with intrusive, which are also termed as plutonic igneous rocks. Okay. Because the magma in the crust cools at slower rate and have enough time to result into the formation of larger size of crystals. Okay. So, example of such type of rocks are granite and pegmatite. Okay. There are more also, but these are few examples for that. Okay. Then we look at the diorite. Okay. So, we are looking at the pheneritic coarse grain rocks. So, how the diorite looks like. Okay. Diorite is an intermediate rock again. So, we are having the whiter part is mainly the plagioclase feldspar, and then we are having the darker ones are amphiboles. Okay. So, it looks like so it is comparatively lighter. Then we are having the gabbro. So, as we are moving towards the right, then we are getting into the mafic rocks. Okay. So, we are having felsic and mafic. Now, we can look at the gabbro. It has comparatively it is darker in color, and the composition what we see is again the feldspar is there, plagioclase feldspar, and darker ones are amphiboles. Okay. So, percentage of silica will reduce here, whereas the ferromagnesium minerals will increase. Okay. And then we are having the ephenitic fine grain rocks. We are having rhyolite. So, let us see how rhyolite looks like, and basalt. Okay. We will keep both together and try to see. Okay. So, ephenitic texture is characterized by fine grain minerals which can be seen under microscope. Okay. Because the size is less than 2 mm or. Okay. So, commonly associated with volcanic, we say, so those were the plutonic, and this is volcanic extrusive rocks, because magma on the surface cools faster and result into the formation of very fine crystals. Okay. So, example is basalt, andesite, rhyolite. So, this is a rhyolite which is comparatively lighter in color, rich in felsic minerals, and basalt is darker in color, more rich in mafic minerals. Okay. So, again basalt we see it is fine grain, and this is also fine grain. So, origin, and then if we take the texture, that is an extrusive rocks. If you look at the vesicular nature, okay, or the texture, then we have pumice. Okay. This is comparatively very light rock which is having the cavities within it. Okay. So, this is again cavity rich, very light in comparison with the other. So, it forms during the fast cooling process of the magma containing gases. Okay. So, the eruption or the removal of the gases will result into the left out pores, what we call the vesicles. Okay. So, comprised of vesicles that represent the gas bubbles that were been trapped during the rapid cooling of magma. So, when they are released, they will result in the left outs are the vesicles. Abundant vesicles and the thin layer gives the rock a very low specific gravity, which is less than 1 g. Okay, so this is again and very lighter rocks, allowing with an ability to float on water. Okay. So this is one of the very important and characteristics of the pumice, which is we termed as an vesicular rocks. Okay, and this is an extrusive rock. Now, just to look at that where exactly this type of rocks were been formed, and then most important part here what we are going to talk is that why we are having so many or so much of area which is covered by your volcanic rocks in India. Okay. Why we see the Deccan Plateau, okay, which is comprised of the volcanic rocks. Okay. And what was the reason? Because we don't have any volcanic eruption right now, but probably had in the past. Okay. So if you remember, we talked about the plate motions and all that, and then we talked about that the earlier all plates were together, and finally they departed from the landmass which was known as Pangaea, and in the Indian subcontinent particularly it moved from the south of the equator and reached north of equator. So during this journey probably it came across the process of volcanic eruption, and that is one of the reason why we are having the volcanic rocks in India. Okay. So let us see and try to look at that why we are having the volcanic rocks in India, what we call the Deccan region. Okay. So if you look at the large area of the Indian subcontinent is occupied by the Deccan Plateau, which is comprised of volcanic rocks. Even we have few in Kutch region also, and in this region also we are having a lot of volcanic rocks. Okay. So the occurrence of volcanic rocks seen in India, example the Deccan Traps, locations in Maharashtra, some part of Gujarat and MP, and this volcanic rock occupies almost 2 lakh square miles of the area in India. Okay. So very large area has been occupied by the volcanic or the igneous rocks, we can say. Okay. So these igneous rocks were formed near the end of Cretaceous period. Okay. That is around 65 million years ago, due to volcanic activity when Indian continent started drifting from the main Gondwana land. Okay. So the main Gondwana land was located, like it was been suggested that the main Gondwana land was the area which was been occupied. So this was the main Gondwana land. This is what we see. Okay. So when it started drifting from here, it came across, like it experienced the volcanic activity during that period, and it was almost like 65 million years back. Okay. And this is what we call traps, and this traps gave good building stone. Okay. So if you see that this has been used at various places. Okay. And also it gave us a very fertile clay loam, particularly suited for cotton cultivation in this particular region. Now just to see that what are the different type of but this we have already discussed, but I'll just move very fast that the different events. Now these are all events which are been related with the volcanic eruptions. Okay. So Permian Triassic boundary was the major event, almost like 248 million years back. Then we are having Triassic Jurassic boundary, which is around the event again was related to the eruptions, and the major species were been like the extinction of major species during this period also. And then we are having Cretaceous Tertiary boundary, which is around 65 billion years back. Okay. So we have, these are the events which are again probably were been related to the major eruptions in the region. Okay. Now coming to the texture again, and then we look at this examples of the pegmatites and pheneritic and porphyritic texture. Let us see this one. Okay. Again the pegmatites. So we are having very large crystals. Again, these are the plutonic rocks and having the crystals greater than 1 centimeter. So it looks like something like this. Okay. So what we are having, it forms at the late stage in the process of crystallization. Okay. And then we are having the porphyritic texture. It is a distinct mixture of large and fine grained minerals, okay, together. So this happens when slow cooling is followed by rapid cooling. So phenocrust are termed as, like larger crystals are termed as phenocrust, and the matrix, which is the ground mass, are the smaller crystals. So we are having larger crystals and we are having the finer ones, which are termed as the ground mass. Okay. And then we look at the andesite. Okay, and the andesite is mostly what we see is the porphyritic texture. Okay, so we see the larger ones, which are phenocrusts, and the smaller is your ground mass. Okay, so mostly the hornblende crystals have been seen, and then ground mass is mostly the sodium and calcium calcic feldspars. Okay, so that is in ground mass. Okay. So if contains more than 50% larger minerals, then they are termed as porphyries. Okay. So this is another terms which has been given to the rock based on the texture, that if it comprises or contains 50% of larger crystals, okay, then they are termed as porphyry. So this is an example of andesite porphyritic texture. Then volcanic rocks like glassy, which we see is one of the best example is the obsidian, and this is because of the rapid cooling of lava causes the minerals to form tiny crystals or glass like shape. Okay. So this is one of the example for the rapid cooling. Okay. Then we are having pyroclasts, and these are mostly related or been seen or observed during the volcanic eruptions. Okay. So this comes, the rock fragments are thrown out of volcanic cone during the time of eruption, and based on this, the most of the volcanoes are also classified whether the volcanoes are having the capability of putting ash during the eruption, or they are having the characteristic of putting out the pyroclast. Okay. So we say pyroclastic flows, or it is having the lava flow only. Okay. So this will be ejected in the atmosphere. Okay. So based on the shape and size, they are characterized as the smallest are called ash, which is having the less than 4 mm or the clay size. Okay. And then we are having slightly larger are termed as lapiles, which range in size from 4 to 32 mm, and the biggest are called as bombs, which are greater than 32 mm. So all this can be classified as an pyroclastic flow. Okay. So thank you very much. We'll continue in the next lecture.